Okay, this is Florence, the mathematics user, and we are looking at binomial theorem. Basically, binomial deals with two terms. So a binomial is an expression which is made up of two terms. So we have a plus y. This is a binomial. Now, when the powers given for a binomial is high, let's say 6, 7, 8, 9, 10, so it becomes difficult for you to expand. So there are various ways we can use to expand binomials with greater exponents. And one of the methods we use is the Pascal triangle. Now, we want to understand the Pascal triangle very well because it helps us obtain the coefficient of given binomials, and it makes it easier for you to expand. So for example, if we have a plus y all to the power 0, we've learned from indices that any number to the power 0 is 1. So a plus y to the power 0 will give us 1. Let's take another one. A plus y to the power 1 is going to give us a plus y. Now here, let's look at the coefficients of the a and the coefficients of the y. You get to see the coefficient of the a is 1, and that of the y is also 1. Let's continue. When we pick a plus y to the power 2, when it is expanded, you have a plus y here. Then a times a gives us a squared. A times y gives us ay. Y times a, ay. And y times y gives us y squared. Where we have a squared plus 2ay plus y squared. So a squared here plus 2ay plus y squared. Now, I want us to deduce something here. When we look at this part, we have 1. When we come here, you get to see that the coefficient of the a is 1, and the coefficient of the y is also 1. Here, the coefficient of the a here is 1. The next one is 2. Then here, it is also 1. So there is a pattern here. You get to see that for you to obtain each successive, for you to obtain a coefficient of each successive binomial, it is the repetition and the summation of the values in the row before. Here, 1 is repeated. 1 plus 1 gives us 2. Then this one too is repeated, giving us the coefficient of, into bracket, a plus y to the power 2. Then it means that if we have a plus y to the power 3, there's going to be a repetition, and at another point we are going to sum up. So we repeat the first value here, followed by the summation of the adjacent values. So 1 plus 2 gives us 3. 2 plus 1 gives us 3, and it is repeated. And then is the Pascal triangle. Let's pick another one. A plus y to the power 4. 1 is repeated. 1 plus 3 is summed up. 3 plus 3 is also summed, giving us 6. 3 plus 1 is summed up, giving us 4. Then this one is repeated. So this is the Pascal triangle. But when we get to exponents such as 8, 9, it becomes difficult because you waste time. Let's pick another one. A plus y to the power 5. is going to give us, we repeat this one. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5. Then 1 is repeated. Which means that when we expand a plus into bracket a plus y to the power 5, we are going, the coefficient will be 1, 5, 10, 10, 5, 1. That's this with the Pascal triangle. Now, so we are going to use this to expand what we have here. So let's take note of that. Now, the next thing to do is to look at how the coefficient of each value will increase. Let's start with a plus y to the power 3. Now listen, when it comes to the coefficient, when it comes to the exponent of the values within the bracket, as one increases, the other one reduces. So we always start with the first one, which will have the exponent of 3, and this will have an exponent of 0. Why? Because at every point in time, when the exponents are summed up, we must obtain the given exponent. So let's break this one down. So we have for a plus y, we note our coefficient. We have 1. Then this a to the power 3. And we know that in mathematics, 1 before a variable can be ignored. For a to the power 3, we come here. The next coefficient is 3. But now, the exponent of the a will reduce by 1. Then that of the y will increase by 1. So a to the power 3 now becomes a to the power 2. And here, y was absent, which means y was to the power 0. It becomes y to the power 1. Plus, our next coefficient is 3. A to the power 3, a to the power, now here it becomes a to the power 1, and y becomes to the power 2. Then, the next coefficient is 1, which we can ignore. But here, a to the power 1, it becomes a to the power 0, so we take it out. But y increases, and we have y to the power 3. So at every point in time, when the exponents are summed up, we need to obtain the power here. So for this, we have 3. Here, 2 and 1. When summed up gives us 3. Here, 1 and 2 gives us 3. Then here, 3. So as the exponent of the first term decreases, the exponent of the second term increases. And the change is just 1. Let's pick another one. A plus y to the power 4. Now we've deduced the coefficient. We have 1, 4, 6, 4, 1. Which means as we expand this, we are going to have 5 terms. For the coefficient of the first term is 1, so we ignore. So we have our a here to the power 4 plus, okay, let me write this here. So we have a to the power 4 plus, our next coefficient is 4, but now a to the power 4 will reduce by 1, and y will increase by 1. So that when the exponents are summed up, we obtain this. Plus, the next coefficient is 6. We have a to the power 2, it is decreasing, the y increases to the power 2. Followed by plus, the next coefficient is 4, but here a to the power 2 will decrease, we have a to the power 1, then y increases, we have y to the power 3. Followed by, the next coefficient is 1, which we can ignore. But now a to the power 1, as we move, it becomes a to the power 0. But y to the power 3 increases and becomes y to the power 4. which means that when this is expanded, we have a to the power 4 plus 4a cubed y plus 6a squared y squared plus 4ay cubed plus y to the power 4. And this will be the expansion. Okay, let's also try that of to the power 5. And I will give it to you to try your hands on. Thank you. Okay, so for into bracket a plus y to the power 5. And we've already done this. Now let's expand. So for the first time, the coefficient is 1. So we have a to the power 5. The y is y to the power 0, which is 1.